Well, welcome. Hope you enjoyed those 3 videos on the excluded values and a couple examples of how to get started with multiplying and dividing. And I hope that was enough for you to be able to work with your table groups to kind of get through some of these problems. So let's take a look at this first one that you should have done together. First thing I want to do is do some factoring. So I look at the numerators and denominators. On this problem we have 3 terms that are pretty simple. They're linear binomials, and so I'm just going to wrap some parentheses around them because they only have GCFs of 1. This other one is a quadratic. I'm going to assume it can be factored. I'm looking for factors of 70 that subtract to be 3. So I'll come over here and start breaking up 70 until I find 2 that are going to work for me. 3 doesn't work, 4 doesn't work, 5 goes into 35, 7 times 2, 14, 7 goes in 14, 2 times 5 is 10. There are the 2 problems that I'm looking for. So it's going to be x subtract 10 and x plus 7. And when I'm doing these rational expressions, I like to keep things clean and neat. This is really messy now. So I'm going to do a quick rewrite of everything I've done. So in the numerator, x minus 10, x plus 7, x plus 6 in the denominator, and the second fraction. Okay, now we can start cross-canceling or cancel like we do with normal fractions. I'm going to look vertically or diagonally to see what will cancel out. So I should notice that x plus 7, x plus 7, x plus 6, x plus 6. And I'm left with only an x minus 10. And that will go over here on the answer part. All right, the next thing I need to do is find my excluded values. And as was stated in the videos earlier, it's what makes your denominator 0. And we're not allowed to have a denominator of 0, so that means those are the x values that we're not allowed to have. So as we saw, we take the denominator that's given to us and we set it equal to 0. Well, we don't want a 0, so I like to throw a slash through my equal sign. So it says x plus 6 does not equal 0. Then I solve these. So that means x cannot equal 6, x cannot equal negative 7, and I write those down over here. Okay, let's move to the next one. Once again, we're going to do some factoring. I have a simple linear factor right here, binomial. These 2 are also easier, but they do have a GCF, so I look for the GCFs, which is 6 in that one, and then 18. Maybe you found a smaller one, like a 2 or a 9 or whatever, but it definitely has an 18. And then hopefully by now you're noticing that that's a difference of squares. So that's going to be an r plus 4 and an r minus 4. All right, once again, it's pretty messy. I want to clean things up. So I'm just going to rewrite everything I've done to make it visually easier to see what I need to get rid of. All right, so I should notice I have an r plus 2, r plus 2, r plus 4, r plus 4. But then don't forget the 6 and the 18. So that's kind of like a fraction 6/18, and that's going to reduce down to 1/3. All right, now I'll put everything back together. And in the numerator, I have 1 times r minus 4, which is just r minus 4. And in the numerator or denominator, I have a 3. So that's my answer, r minus 4 over 3. There is a second way of writing this one. You could also write it as 1/3 of r minus 4. Once again, we have to do our excluded values. This time it's the variables in r. R cannot equal. Go back up here to the original problem. R plus 4 cannot equal 0, And I only need to do this little part right here. R plus 2 cannot equal 0. Solve those real quick. Subtract a 4, so R cannot equal negative 4, and R cannot equal negative 2. Okay, we're going to do one last example together before we do division. Once again, I'm trying to look to factor. I have a linear binomial here. Now the other two are quadratics. I'm just going to assume I can factor them. So I go ahead and go through the motions. Breaking up p squared. I want the factors of 40 that subtract to be 6. And some of you are probably finding them pretty quickly. Otherwise, we're just writing them one factor at a time. 2 times 20, 4 times 10, 5 times 8. I'm looking for the 2 that subtract to be 10, and there they are right there. So I want a negative 10 and a positive 4. Over here, break up the p squared. Factors of 24 that subtract to be 2. And there they are. So minus 6 plus 4. And once again, pretty messy. Come down here, clean it up. Have a p minus 6 and a p plus 4 over 20p squared times p minus 10. And then the denominator there. And once again, I go look what can be factored out. So you should notice a p minus 10 vertically, p plus 4 diagonally, and you have some stuff left over. So I have a p minus 6 over a 20p squared. Don't make the mistake of thinking the p's cancel, because it's all of this that has to go, not just part of it. All right, p is our variable. So what are we not allowed to have? Again, it goes back up to the original. Right there, there, and there. So those two are usually, by the time you start understanding how excluded values work, these are pretty basic. But just like when we were doing polynomial functions, for some reason students always forget that this is a 0. So p cannot be 0, nor 10,